I think to myself, I want to provide environments as a service. So what do I really mean by that? I mean, any application team can decide we need to spin up a new microservice or a new data pipeline or a new AI workload, and I need environments. Containers and Kubernetes were a big catalyst, I think, because there's always been, I think, like extremely good, system administrators, infrastructure engineers. But I think containers was probably like the first time there was a really good interface between those two disciplines. So the people coming from more of the infrastructure, the SysOps background, they're going to have more of that knowledge. And the software engineers are going to have the better software engineering. But really, we need both sides to learn both. One of the most fundamental features that we put in every platform is something called continuous load. So we deliver the platform, and inside the platform, before any developer ever uses it, there is, I think, something that is constantly dripping traffic all around the cluster, so that we actually find out about issues before the application teams find them.
This episode is sponsored by Code Engineering Consulting Group. Hello, welcome to this new episode of Hack Cypress podcast. Today we have Christopher Batey with us from CECG. CECG is our sponsor, so thank you for that, Christopher, and welcome. We're gonna talk about platform engineering again in continuation to our last podcast with Joseph. But before we start, tell us a bit about yourself. You are the CTO, right, in CECG?
Yeah, that's right. And yeah, thank you for having me. So yeah, I'm the CTO, but my background is software engineering. I was a software engineer for 10-ish or so years, working in Java, C++, all sorts, building concurrency libraries and various other things. And then the last 10 years, I've been doing more infrastructure, platform engineering, and then, founded the company with Joe. And now we help other companies doing platform engineering.
All right. And you've been located in England?
That's right. Yeah. I've worked in England most of my career, but spent a year in Cyprus and Nicosia too.
Okay. And did you study computer engineering or did you study something else?
Yeah, that's right. I studied computer science and did a master's in computer science, and then went on to work at IBM initially a long time ago, working on mainframes and things.
Okay.
And then got more into the modern world. Yeah.
All right. And now in CECG, you're focusing on platform engineering, right?
Yeah, that's right. So as CTO, I help bring the three areas of our business together and make sure we all focus on platform engineering. So whether it be consulting, our developer platform product called Core Platform, or our subscription customers. So people who want support and help to run their own platform engineering teams.
All right. We'll get back to that internal platform you are building. Mm-hmm. But first, tell us about a bit of history about platform engineering. How did it start? I would guess that it had to do with Kubernetes, right? Kubernetes could enabled the platform engineering world.
Containers and Kubernetes were a big catalyst, I think, because there's always been, I think, extremely good, system administrators, infrastructure engineers, helping software development teams build software. But I think containers was probably the first time there was a really good interface between those two disciplines. Mm-hmm. And it was an interface which kept both sides happy. Developers were really happy to build into a container image and, package everything they need. And system administrators, infrastructure engineers who, later became platform engineers could deal with all sorts of different types of applications using different technologies, using the same abstraction. I'm sure some of the listeners remember back to when you used to build software and, different infrastructure teams would ask you to build an RPM or a deb package, or some might say, can I have the jar file or some other artifact? It really unified it. And then I think Kubernetes really kind of sealed the deal by the fact of winning the orchestration wars, right? So if you've got all of your application teams building containers, how does then your platform engineer or your infrastructure engineer work out how to deploy those across a set of nodes? So I think Kubernetes really worked there. And I think the reason it succeeded where others didn't, etc., is it was very high quality, but I think the fact it was extensible as well. And Kubernetes by itself doesn't meet most companies' needs, but by design it's extensible, so you can build your own version of Kubernetes with its own characteristics.
And we've seen it happen, right? We've seen different distributions in different cloud providers. We've seen Red Hat building one of its own, Rancher as well.
Yep.
Okay, and can you remind us the other platforms that were against, let's say, Kubernetes?
Yeah, certainly in our experience, the founders of CECG, we had that decision to make back in, I think the first platform we helped build on top of Kubernetes was in 2014, which I think was the same year Google released it. And we did like a big active like POC, not big in time, but certainly in effort. So it was Mesosphere versus Kubernetes, and there were other players out there that came about like Docker Swarm, etc. And I'd like to say we had like the wonderful foresight, but we were a bit lucky and we picked Kubernetes.
It wasn't so clear that back then.
It wasn't clear, but I think the fact it was built as extensible from the ground up was certainly one of the key factors why we chose it. And most companies are building like their own custom platform and encoding their own standards into their platform to make it their platform. And I think Kubernetes is really built for that.
All right. You've said before that the sysadmins, were happy about the solutions and the developers.
Yeah.
And the sysadmins evolved to be today's platform engineers.
Yeah, in some cases, yeah.
I would like to talk about that. Which background do you think is best for a platform engineer to start on? Is the developer side or the CISOP side?
I think it can be either. We hire from both backgrounds, for instance. I think if I look for like the perfect platform engineer, we probably should define what a platform engineer does to justify this explanation is I think they have to be a software engineer. Like that you have to be able to solve problems with code. But you also have to have deep infrastructure knowledge, right? Yeah. You have to understand networking and cloud and IAM, etc. So the people coming from more of the infrastructure, the SysOps background, they're going to have more of that knowledge. And the software engineers are going to have the better software engineering skills because to build effective platform solutions, you need to be able to, build immutable artifacts, do testing, extend Kubernetes, write your own operators when it's needed, etc. So the software engineers are going to find that easier. But really, we need both sides to learn both. And the best platform engineering team probably has a mixture of backgrounds. Even though everyone's trying to learn a bit about everything, they have deep software engineer experts and what I'd say deep infrastructure domain experts.
With some specializations in each of the developers in the team.
Yeah, exactly.
But from your personal experience, which do you think is best for a junior engineer to start on?
I think I'd say the best thing to start on is fundamentals of a bit of everything. So I would say software engineering, being a good programmer, I think is one of the first things, but then also getting outside of the IDE. So very quickly, understanding the system you're actually deploying software to. So understand Linux, understand a bit about the kernel, understand how memory works, etc. As a platform engineer and debugging and root causing things when they don't go to plan in your platform, those are the skills that are really going to help you.
All right. So stop using the magic buttons, let's say.
Yeah, exactly. And when things don't work, see it as an opportunity to dig in and learn something about why it's not working. And I think some of the older platform engineers that grew up with this technology, it was a necessity. If you tried to run Kubernetes in production in 2015, you were pretty much going to be debugging this stuff on a daily basis. Yeah. But that's not the case anymore. So those problems still do happen where you have to get in and debug things. But you won't get as much experience by default because everything's a bit more reliable these days.
A bit more abstract.
Yeah.
Okay. We've talked about platform engineering and platform engineers.
Yeah.
I want to go back and understand what is platform engineering in a technical level and what does the platform engineering actually do on a daily basis. So I would imagine infrastructure as code is part of it, cloud, the IDP, the internal development platform. But I want to hear it from you.
Yeah, I'd go one level up first just to show how important it is. But I'd say at the top level, platform engineering I see as an organizational model. It's actually where you put your engineers and what their responsibilities are. Because I see the migration is we used to have traditional operations, right? That's when if I was a Java developer, I'd build a jar, right? And if and then I'd pass it to operations and they would package it up into some kind of, RPM or Deb and they'd put it on a machine and they would run it. And sometimes that worked. And then DevOps came about and tried to reduce those two silos and align people, and then also introduce new technologies like infrastructure as code, automation, more pipelines, etc. Though I also think a lot of the sysadmins, the good sysadmins, did a lot of that anyway, even in the traditional operations.
But maybe that the DevOps principle that got introduced, maybe they shift the responsibility towards the developers rather than the SysOps back then.
Yeah, I think if you take I'm going to call it a popular way to implement DevOps not DevOps, is that you would end up with, say, okay, let's get our software development teams to start delivering services rather than artifacts. So stop building a jar file. That's maybe on the way, or whatever artifact it is for your programming language. Like, you develop a service, and the common phrase you often hear is like, you build it, you run it, right? And then a really popular implementation was that we ended up with multifunctional teams, right? So we ended up with software engineers next to cloud experts, all in the same team, etc. So every value stream team, or any team that was like going to build something, they would have all the expertise in there. Now,
to deliver it themselves.
Exactly, themselves. And there's two big downsides to that. A, it was a step in the right direction, because I think if someone operates something in production and they're building it, they're going to build something which is operable, which is not the case necessarily if they're not operating it in production. But the two problems I think that came about, or certainly in my experience, like, the first is hiring, right? There are far fewer people in the industry right now that have the infrastructure and cloud skills. So if you had 3 software engineering teams, maybe it worked for you because you could hire 3 of those like cloud experts. But if you had 20 or 30, I don't know how like people listening, like their organizations, but you really struggle to hire 20 or 30 of those people.
So the scalability problem.
Yeah. And then let's say you did manage to hire enough people to have like, you build it, you run it, multifunctional teams. Then what you often end up with is people going in different directions.
Standardizations.
Yeah, because like you end up with teams that their main focus is delivering the next bit of business value. And, that's a good incentive. That's what they're trying to do. So they'll do things the quick way, which is I'll just write, the Terraform to do this because it's the quickest way and I won't coordinate. So I'd call that a traditional like modern like DevOps implementation. It's not the only way to implement the DevOps principles. And out of that often came these like centralized infrastructure and DevOps teams, where you take a few of those, or you'd rotate them around like a central team, and that team would be responsible for things like golden templates or the best libraries and the best tools, etc. And again, I think that's an improvement. But in my experience, what I've seen happen in those organizational setups, and this is why I call platform engineering an organizational setup, because it's where you're putting your engineers and what responsibilities you're giving the teams, is the people in that central team often write software, code, infrastructure as code, libraries, tools, that they then don't operate in production because they're actually giving it to all these teams to use. And unless you have really good culture where these people work collaboratively and basically it's like a distributed like virtual team, you end up with this diversion where each of the value stream teams think, oh, that person doesn't understand what this Terraform library is that, maybe manages some VMs and sticks a database on them or something, because they don't actually run it in production. They don't get, called out for that. So that brings me on to like the difference between that and platform engineering. And like for me, like platform engineering really is when that central team is delivering something which is self-service. So that's the first one. And self-service doesn't need to be too fancy. It can be like a PR to a Git repo. It could be a developer portal. It could be any kind of interface. But the thing that's provisioned, the team which wrote the code to provision it, so, the team behind the button or the team behind the PR is operationally responsible for it. So let's take a concrete example because it's getting a bit abstract.
Yeah.
Let's take application environments. So let's say you need a place to run your microservice, right? The old way of doing it in some DevOps implementations would be there might be a team which produces a Terraform library, which, spins up, I don't know, a Kubernetes cluster or ECS or something like that. And then these other teams would use it, but the team that wrote it wouldn't have anything to do with like the production instance of the Kubernetes cluster, et cetera.
Yeah.
And that's where I think the problems lie. Whereas with platform engineering, that team would allow some self-service onboarding to say, I've got a new microservice coming. I need environments. Maybe I click a button in a portal. Maybe I raise a PR to a config repo. But then the actual Kubernetes cluster behind it, or the namespaces, the platform team are actually operationally responsible for. But the application running inside the namespace, the application team are operationally responsible for. And it really just goes back to, you build it, you run it, right? So if you write the code for the Kubernetes cluster, you're operationally responsible for the Kubernetes cluster. If you write the code for the microservice, you are operationally responsible for the microservice. And that suddenly then aligns incentives. Every bit of code you write, you're managing in production. Versus the more like template library approach to standardization.
Okay, so you give the developers the tools to be able to to create what they will be running, and that gives them the incentive to know how it runs and to operate it, and to, if it fails, they would have the ownership of knowing why it failed and do something about it.
Yeah, I think the only caveat I'd put on that is if the application fails, say it fails to start or a request fails, etc., I would want the developers to be operationally responsible for that. If the underlying platform failed, so let's say the Kubernetes cluster crashed or like stopped working, etc.
Sometimes, though, it's not really distinguishable, right?
Yeah, exactly. So I think, but I'd say like the best way to make it distinguishable is that you build it, you run it, right? Because the first time it goes wrong, eventually you'll root cause it to what actually went wrong. It won't be obvious at the start, and maybe before you're monitoring and alerting and self-healing is less mature, both sides might get called out, right? But then it's going to result in someone eventually working out, it was a Kubernetes upgrade or it was an application upgrade. And then that team is going to be really, really incentivized to make sure that the alerting is improved, the observability is improved. So it's really obvious whether it's their thing that's broken and they can fix it in a minute rather than an hour, or whether it's not their thing. I'll give you an example. So for most of the platforms that we build, hundreds of developers are using them. And there's lots of different microservices running on. And there might be an incident where one of the application teams says, the traffic between my microservice and the other microservice, I think some of the requests are failing, and I think it's the platform's fault, right? And of course, how could you argue with it? Everyone gets on, they try and root cause it. So one of the most fundamental features that we put in every platform is something called continuous load. So we deliver the platform. We deliver the self-service interface for you to get environments on the platform. And inside the platform, before any developer ever uses it, there is, I think, something that is constantly dripping traffic all around the cluster, between AZs, between regions, if it's a multi-region, etc. It has monitoring, it has alerting, so that we actually find out about issues before the application teams find them, right? So if Amazon's status page says green, 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 but that inter-AZ traffic is failing for some reason, our continuous load monitor would pick it up. And then, so as soon as an application team says, I think it's the platform's fault that my application couldn't talk to another application, hopefully we've already reported it to Amazon. Or if it's actually nothing to do with us and it's actually a problem with a thread pool in one of the applications, we would be able to point to say, during that time period, we sent, 1,000 requests, 10 TPS at this latency, with no failed requests between those two nodes, right? So that's an example of where, because we're operationally responsible for the platform, we build those things. And if anyone's interested, that component is actually open source and you can use it in your own Kubernetes clusters. Continuous load.
Okay. Yeah. So it's like you're doing the job of Amazon, because essentially Amazon is providing a platform for you.
Yeah.
But you are building a new platform specifically for the developers.
Exactly, yeah.
And you are providing the same services like Amazon is to the cloud engineers.
Yeah, we obviously try to build at a higher abstraction level and hopefully more custom to developers. Because Amazon's got EKS, it's a good service, etc. But if you raise that support ticket with Amazon to say, I think my application A is not talking to application B on my Kubernetes cluster because of Amazon, you're going to wait a while before you get a response on that ticket, etc. They're not going to know anything about your domain or your applications or exactly how you've configured EKS. So I think we're just looking to building value adds on top of things like EKS. So we've built platforms long before EKS existed, and we used to have to, build Kubernetes directly onto VMs and install everything ourselves. So things like EKS have sped up the development of platforms so much quicker. But it doesn't mean that platform engineers don't have a job. It means we can put more effort into things like the user interface or the day-to operations of the clusters, etc.
Maybe security is also affecting this, because some companies would have more security on their EKS, some less.
Absolutely.
So platform engineers would need to ensure that the requirements of the security requirements are met for those development teams.
And I think it's another benefit of platform engineering and how it's much more like a ways of working or organizational model, because I think the great thing about having a centralized, say, multi-tenanted platform is that you as the platform engineer can do that role, right? You can go to security, find out their requirements, and decide, maybe 80 to 90% of them you can build into the platform. So then applications, by virtue of being deployed to your platform, adhere to 80 to 90% of the security requirements. There are always going to be things at the application level, which the platform are. They might provide tools, but there might be some authentication or encryption that has to happen for certain customer data. That's probably going to be in the application. But absolutely, if it's things like image scanning, endpoint protection, etc., it's much better to go to one central platform team than it is to go to like 20 different app teams and make sure they're adhering to the standards which can be built into a platform.
I want to hear more about that. So how are the platform engineers you're essentially saying that the platform engineers should consult with the rest of the departments in the company, especially if it's a big company, get the requirements, like security requirements or reliability requirements and all this stuff, and essentially build it into the platform for the developers to have it with the click of a button, let's say.
Or a deploy of a pipeline.
Deploy of a pipeline, So how would the platform engineer, is the security department going to evaluate the platform engineer's job to say, okay, you've adhered to all of my requirements?
One of our core principles as a company is come with a plan, and I'll use that as an example. So it depends on your security department. So I think a lot of security departments are starting to learn about the underlying technologies like containers or Kubernetes, etc. But typically, I would say it's the platform engineer's job to interpret the security department's requirements, and they'll be at different levels of detail depending on the organization, and then come back with a plan to the security department to say, okay, let's just make one up. Let's say that vulnerabilities in nodes need to be fixed within n days, right? So we could come back with a plan which shows like our automation around like infrastructure development lifecycle, which is like how we deploy the pipeline, and we can show how we'll build in detection of vulnerabilities into the node images and do an automatic release, etc. So we always kind of come with the plan for how to implement security's requirements.
All right. This episode is sponsored by Core Engineering Consulting Group. CECG is a principle-driven strategic advisory led by expert engineers who have been at the forefront of platform engineering from the start. CECG empowers software development teams to achieve unmatched speed, security, and scalability while optimizing costs. And you said that sometimes it could be a simple thing to get self-served, like a pull request in a Git repo. So I would imagine that there are multiple phases into starting with platform engineering and how the developers would get served. From your experience, usually how are these development teams start collaborating with a department like a team like platform engineering to get started on being self-served?
I think there's a few different ways in which it could start, and I'll name them at the high level and then maybe go into one in detail, right? I'd say that the two most common ways are bottom up from the developers. So like say that an area that needs to deliver a lot of like say software services or pipelines, like data pipelines, aren't getting the infrastructure that they need in time, and they often can start like almost like a platform engineering initiative within their area because they and it's all driven by how quickly they need to deliver that piece of like software for the business. And then there's also like platform like more like traditionally infrastructure departments, that are trying to keep up with the times and like serve their customers, the development teams better, and they could start it that way. And the only way that in my experience that works in either of those is, pick a few key business things that need to happen and build the MVP based on getting those pieces of software live. So don't start with like a big, feature spec for your platform and build it for 2 years. Find 3 or 4 bits of software, we call it early adopters, and that are already struggling to get infrastructure, and build your initial features around what the bottlenecks for their software delivery is, right? So if it's access to environments, I would start as a platform engineering team, building environments as a service. If they've already got environments, but everyone's got, manual deployments, you could maybe start looking more at like pipelining and automation around deployments, etc. If you're about to have a big security audit, like external security audit, and you're going to fail it miserably, then maybe look at like the ISO standard before and think, okay, which are the top 3 things that we could work on before like the audit happens. And then as soon as the audit happens, have the plan ready for how you're going to, use platform engineering to like, remediate some of the key issues. So I think as long as you've got like early adopters and actual software which needs to get to production in a fairly short time period, so your first live platform would be, weeks to a small number of months. Don't try and build like some big magical platform at the start, is what I'd say.
Because nobody would use it.
No one would use it. And I think you just have to always empathize with the users, right? As in like, and if you're doing it, if the definition of success for your platform is these 5 applications go live, it'll set your scope. Because there's so much scope. You could Google what capabilities could my developer platform have, and you could build capabilities for the next 4 years. Right, but if the hardest part is picking like what to do out of that list.
Yeah, how do you handle legacy systems inside a company that it might be a bottleneck for you to automate things?
Yeah,
would you start by totally migrating that legacy system into something that is more modern and could be integrated in with APIs and automation, or would you adopt a new system in parallel with that? How would you go do that? And especially if it's a legacy system, maybe upskilling would be required as well for those.
Yeah. I think everything you do inside engineering needs to take into account like the people and the skills they have and like where they want to go. So if you've got a large legacy system in production, but it's like generating value for the business, you're not going to get very far if you keep, dissing the legacy system that's actually making money. But I would try and identify the underlying problem. Like, what is the business complaining about? Like, is it reliability? That's a very common one. Is it security, or is it like delivery speed? And pick one of those that your actual business cares about, and then frame everything in terms of that. So if it's a delivery speed, and they want to launch a new product or version 2 of the product or a revamp, etc., I would say, can you build that small bit as an example in a more isolated way? Maybe the old system is just modified to call out to it, some kind of strangulation pattern, which is often called. Show what good looks like, get it to production, and then use that team that used the initial platform, so the team that could now release every day or even multiple times a day, as your advocates. Right? Because then it's not you as a platform engineer trying to convince someone to say, oh, please use my platform. You get the users to advocate for you. And like, if around the water cooler or the coffee place or whatever, they're saying, oh yeah, we've done 3 releases today and, there was a bug fix already fixed in production, etc. And another team takes, months to release, it's going to spread quite quickly. But you may have meant legacy in a different way. It's like maybe you've got tools which are just in your ecosystem, which are very hard to write like automation against. Like maybe you've bought a vendor product, etc., which you can't control with an API. And I think at some point, you as a company need to set like a North Star, right? You need to say, we want to release new features to production every day, okay? And you get everyone, that's the mantra, right? So then even when evaluating, say, I want to bring in this vendor product.
Does it meet the North Star?
Yeah, and you can come up with like an evaluation criteria. Okay, if we want to release changes to our customers every day, that means we need a lot more control over the things that we're using. Those things typically need to be, API driven. They need to be versions. We need to be able to write good automated tests against them. Because if you've got like systems where you need 2 weeks of manual verification, there's no way to automate that, you're never going to release your software every day, right? So I think it's just starting off with that, North Star mission. And, until you get there, I think often if you start bottom up with the engineering, you can get very frustrated because you'll certainly hit a level in your organization where they're just like, why are we doing this? We're doing it. Whereas if everyone's saying, okay, remember the company goal is to release changes to production, once a day, right? So can we have this piece of software which updates once every 6 months on our support contract, right? Probably not, right? Yeah. And we can't throw it away because it's probably in use. But as we re-architect systems, as we replace things, as we build new features, we can make sure we're moving in the right direction.
So build up a strategy first and then pick up the tool that aligns with that strategy.
Yeah, and it pretty much always boils down to either development speed, security, or reliability. And there aren't many companies that don't want to improve one or all of those 3 things. Yeah. And platform engineering is good at improving any one of those 3 things.
Right. You said testing, automated testing.
Yeah.
How would that apply to infrastructure?
Yeah. So if you think about, let's take a concrete example. So if I think to myself, I want to provide environments as a service. So what do I really mean by that? I mean, any application team can decide we need to spin up a new microservice or a new data pipeline or say a new AI workload, and I need environments. So I go to the self-service API, whatever that is. It could actually be a HTTP API. It could be a developer portal. It could be a pull request to a Git repo. And then, I make the self-service request, and, there of course can be approval flows from like finance and compliance, these things. That's fine. You can build those in. But the end result is that development team should have an environment, right? So you as a platform engineering team, how do you make sure that works, right? Because suddenly you're moving away from a model where you might get a ticket on your queue to say this team needs a new environment. And maybe you write some Terraform, or maybe you click some buttons inside a console, and then you'll check it works, and then you'll give it to them, right? The idea of building self-service capabilities is you build the capability, people can request it, and you're then building the next capability. You're not managing the other one. You might be operationally responsible for it if it breaks. So the best way to do that is to treat those capabilities like your business would treat its key pieces of software.
Yeah.
So if I'm thinking about how I would develop that capability, well, there's many different ways you could develop it. It could be a multi-tenanted Kubernetes cluster where a parent namespace has the permissions of the underlying team. So the RBAC and, SSO and things are set up for it. So if I was developing that feature, it's probably going to be, it could be some Terraform is triggered. It could be an operator running inside that cluster, which, listens to that config file or that request and then creates it, etc. But really it's got an input, which is the request, and it's got an output, which is some namespaces, right? So that's just a test for me. So in an environment before developers touch, so an environment that only infrastructure have access to, every time I change that Terraform or change that operator, I would want tests to run to verify the user-facing behavior, right? So it would exercise the API, and it would make sure that the users got what you thought you were giving the users. And taking that approach, and for me, that's really the only way that like infrastructure and platform engineering scales, right? Because you're going to keep on building new features. And I don't want to be going and checking like the first 10 I built 2 years ago still work.
Breaks, yeah.
And I want to develop other engineers in my team to be able to go modify those features. And when I'm reviewing that, I do my best to review Golang, Terraform, CloudFormation, but I'd much rather verify the tests they wrote. Like, does it still work?
So
and does it pass?
it essentially becomes a software, right?
Yeah, absolutely.
So the automated testing is like building unit tests for your software.
Yeah, I'd say more like functional tests are what more. We do write like a lot of unit testing as well, but end-to-end functional tests of user-facing behavior are like at the top of the list for like CECG platform engineers. So are you developing a feature which a user is going to use? Can I see the functional test for it?
All right. Okay, let's go to some other questions that I want your opinion on.
Okay.
How do you see this trend going? I mean, you've seen all these different transitions. Mm-hmm. You've talked about them. You talked about CSOps and developers working together, and then the DevOps principles, and then the platform engineers. How do you see this playing out in the future? Do you see platform engineering sticking, or do you see some other shift that might come, maybe with AI or whatever?
Yeah, I think I'd say the industry as a whole isn't there yet, right? So if I were to go into a random company, and the two countries I know the most about are Cyprus and the UK, many people have platform engineering teams. Not many people do platform engineering. So I think we're going to see more infrastructure teams only survive if they're doing platform engineering, where the definition of success is, can the business release software more quickly, right? Which I think works better if there's platform engineering in place rather than more traditional infrastructure engineering. What I imagine is a lot of it's going to become more like commoditized, right? So a bit like Kubernetes has become commoditized. We used to, as platform engineers, have to get the latest Kubernetes release from the downloads page. We used to spin up VMs. We used to install etcd. We used to that's all the stuff we used to do. I haven't done that now probably for 8 years, right? Now I build our platforms on top of EKS like GK or AKS in Azure, right? But it just means we can do better things at the user interface level. It means that we can build platforms in 2 months rather than 12 months. So I see the barrier to entry for proper self-service platform engineering, where developers are operationally responsible for their apps, but not the underlying infrastructure, increasing to the point that businesses will have to have it. Because if they're still doing it more traditionally, where it takes weeks to get a new application into production from scratch, they're just not going to be able to compete with their competitors. So I'd say more commoditization, which means we can build even better platforms. Whether things like AI will affect it, well, I think it's the job of platform engineering to make building AI-enabled apps easy, right? So, most businesses now are scrambling to think, how is AI going to affect my application? How am I going to integrate with it? And we might get to the point where it's drag and drop and all those things, but I think we're going to have at least 5 years of software engineers have to learn how to integrate with LLMs and various things. And to do that, organizations need to be able to, have pipelines which test, AI-based applications, how they can do the trade-offs between whether they use models running on their own hardware or using things like, OpenAI or one of the cloud providers. So I think platform engineers can put capabilities into their platform to make those type of things easier. The other big area where I think platform engineering might be affected by AI is through the user interface. So right now, I'd say the two most common interfaces to the platforms that we've got a lot of experience with are config-based in GitHub. So I might onboard as a new team and I might raise a pull request for the YAML with, say, my security group. So I get access and I start, using the features. And then often I request additional features by, putting objects inside Kubernetes. So I might put my corporation best database object in Kubernetes, and then everything just happens and I get a database that I can connect to. That would be like a self-service interface to a database. And then also things like developer portals. But I could well imagine very soon the way a day-to-day product engineer interacts with their platform is to use something like a chatbot. Okay, I need a skeleton app in Java. I need it to have a MySQL database, and I want a path to production that takes it through these environments, and I want skeleton tests for this. And they can just write that.
Yeah,
right?
And then it would be converted to something that the platform engineers built.
Exactly.
And
I fully imagine that would be backed by an application, which then raises a pull request to a, it'll be the same thing in the background. I think one other area which I think AI might really affect platforms and platform engineering is root cause analysis, because I think that the breakthroughs in AI have shown that it is a very good interface to a large body of structured data, right? Platforms produce a lot of structured data. First, there's the docs, right? If you've got really good docs and troubleshooting, etc., and then there's the standardized data, right? So if every application team builds applications in a different way and structures their log differently and does their metrics differently and uses a different technology to host their container, some use ECS, some use EKS. I'll probably get all the acronyms wrong. Then everything's different. But in a platform, typically all the applications are deployed in the same way with the same pipelines. The metrics go to the same place. The logs go to the same place. So if you imagine someone root causing, I think it's very likely that we'll have root cause interfaces to say, my application isn't working in dev. What's wrong? Right. And with combination of training and RAG and various things, I think it can look at your metrics, it can look at your logs, it knows which applications are owned by which teams, and it's got access to your internal knowledge base with your troubleshooting guide. So I think that's another area where we could just speed up root cause analysis.
I think we're already seeing this in an early form, right?
Yeah.
Google built in some tools in Chrome development tools.
Yeah.
Datadog has some intelligent stuff.
And I think if we can augment that in our platforms to be really context aware, because I think companies like SaaS companies and cloud providers, they can always give you the generic version, but you've got as a platform builder, exactly how everything's done. So you can give it way more context and way more structured data.
Yeah, right. Can you tell me some of your favorite tools around platform engineering to help the junior guys get up to speed and learn something that may use in the future?
Yeah, I mean, I think I said it at the start, but I do think the fundamentals are what let you learn all the new stuff very quickly. So I would, if you don't program every day, start programming every day. If you want a specific programming language for platform engineering, Golang is the one there. All the tools are built in Golang around this ecosystem. Some might be Rust, some might be C, some might be a JVM, but most of them are Golang. And as you build these platforms, you inevitably have to debug the underlying bits of technology you're using. You might be debugging the ingress controller, you might be debugging Kubernetes, and being able to read that code is extremely useful. Again, I think it's going to be a long time before platform engineers do not need to understand Linux and how containers work under the covers for doing more like debugging, etc. Understand that if you're going to build platforms, know how to extend Kubernetes, know how to write an operator, understand the pros and cons versus building something into a platform versus giving someone a tool to use outside the platform. An example might be, let's say you need to generate some Kubernetes manifests and you want that to be standardized across your application, across your company. Sorry. Like the two high level ways of doing that are you could build a CRD that represents your company's application, which creates them, right? That's building it into the platform. Or you could give them a Helm chart or a CLI, which generates it. And then your platform doesn't really know about the custom things, but it's built in. So understand how to do like both of those and the pros and cons. That's about it really. Like understand your Kubernetes fundamentals.
Would you say that some of the tools that we have now for platform engineering, mainly for the internal development platforms, like Backstage and some others, may be evolved enough to do all this stuff automatically and creating internal development platforms as a service without the need of the platform engineers?
Maybe, I think. I mean, I do still believe that a developer platform is custom to your organization. Yeah. And now, in the last 10 years, I've built, I don't know how many different developer platforms for so many different organizations, because it's been my job. And 98% of them are the same, right? It's only the lipstick around the edge that's different. So I do think there's a place, and we believe it as a company, because we're building like an off-the-shelf developer platform for
great.
Based off of the experience of like our consulting, etc. But it's the actual like technology in the industry. So what the cloud providers provide, or the CNCF, like open source technology, it's a complete minefield. Like there's so many different ways you can do it, and an organization can spend so much time just deciding which ingress controller to use, which cloud provider to use. Should I have a developer portal? Is it actually worthwhile? How on earth do I what's this stuff like software catalog, and then okay, which CI/CD tools should I use? Once we're using the CI/CD tool, what should the pipelines look like? I don't know how anyone gets anything done because there's just so many different options, right? So
decisions.
So really, I think the value of getting something more off the shelf is the opinionation, even if you don't agree with some of the opinionation, because you stop the months it takes while the developers say we should use, Concourse versus Tecton. And in reality, both tools would work. Yeah. And it's more important what you put in the pipeline, not the tool which executes the pipeline.
As long as it gets the job done.
Yeah. And I think and there's widespread buy-in for it, and you've standardized the pipeline, because that's what actually gives you the power to go and talk to security or change management, when lots of development teams are doing the same thing, and you get the leverage from everyone doing the same thing. So, yeah, right. I don't think there's anything out there really, but I think there could be.
Okay, what's the tool you're currently developing? Is it out or is it?
So it's in beta phase at the moment. So it's closed beta, though we're very close, like probably within days, if not weeks, of opening up like a larger beta. So what it is it's based on all of our consulting experience and building developer platforms. It's a given your cloud provider, so it's your cloud organization, could be AWS, could be GCP. It will install a multi-environment developer platform in there. And once you've done that and gone through that initialization process, it gives the self-service API to developers to be able to request essentially pipelines and environments. So, if you've got an application team and they're struggling for somewhere to deploy their applications, after you've installed our developer platform, it will give you environments, and it will give you a standard path to production. It will give you template applications in like popular programming languages, and it will say, put your business logic here, right? And it will say, put your functional tests here. That said, it's got lots of these kind of what I'd call like paved paths, golden paths in. But if a developer wants to do their functional test differently, or use a slightly different version of Java, you can do that, right? It's here's a way to do it, so you can just get working on your business logic. But there's lots of options for breakout. And
does it integrate with teams that already have tools and have an environment, or is it?
This is designed really, and this could change, and it absolutely could change in the future. But this is designed to be everything you need. Right. So it is the environments. It is the pipelines. But that said, is everyone's got an existing system, right?
Yeah.
I mean, we could like go and talk to someone who's about to start a startup, and that would be fantastic for them because they would save so much time not working out how to initialize their cloud org and set all that kind of stuff up. Great. Everyone's already got one, right? So, and they've probably got like a big system running inside that cloud org. So again, you mentioned migration earlier on, right? So what's the migration strategy? So you wouldn't be talking to us if you didn't have a problem with your existing system. And the problem is delivery speed, security, or reliability probably. So that would be the reason to move. And then there's different strategies for moving, right? So if you're building a new isolated system, great. You can point this thing at a new cloud org or an existing cloud org, and it will segregate an area in that existing cloud org and not touch anything of yours. So they could just coexist. You know, if you want to build a new system, you can just put the new app on there and follow the good, all the good practices on the new side. Typically what's going to happen is people are going to start building like small new things over here and have the old system call out to the new system, see the benefits, realize they can like release and, use the new system like much more quickly, and then slowly move things across or slowly replace things.
Do you provide this migration for the companies that purchase this product?
So what we do right now, because we're in the beta phase, is you get access to a CECG engineer who'll help you do the migration, right? So they're not going to rewrite your application to adhere to continuous delivery principles. So they're not going to rewrite all of your applications to make sure they manage their own schema and have backward and forward compatible APIs, but they'll teach you how to do it. And they'll say, like, as you're migrating like this app onto here or developing this new app, etc., they'll help you do it. And that's during the beta phase. For the full product launch. And when I say beta phase, it's beta because we want to focus on making a small number of customers like really successful with it to start off with. From a production quality point of view, it's ready to run your applications in production, like absolutely. But the goal is for it to be like the platform to be self-service. So you wouldn't even need our help to use it. But of course, that will mean more maturity in, documentation and operations. And we're really learning ourselves because we've been doing platform engineering for a long time. All of our engineers have. And sometimes we aren't the best people to write the documentation for a developer platform for people who are not used to having these types of platforms.
Yeah.
So that's another big value for us for having the beta customers. We think we've fully explained things in, like, we've got CLI, we've got a UI, we've got the docs, and then we see someone's reaction to it and they're like, oh, what's a namespace? And you're like, we need to go a little bit deeper in the docs, things like that. So,
all right.
Yeah.
Well, thank you, Christopher. Thank you. This has been very insightful.
Yeah, it's been a pleasure. Thanks for having me.
And thank you for being our sponsor again.
Yeah, good.
And I'll see you next one.
Okay, thank you so much.